बिस्मिल्लाहिर्रहमानिर्रहीम। आज का टॉपिक है नॉन लीनियर फर्स्ट ऑर्डर डिफरेंशियल इक्वेशंस। वी आर स्टार्टिंग विद द नॉन लीनियर फर्स्ट ऑर्डर डिफरेंशियल इक्वेशंस। द डेफिनेशन इज दैट द डिफरेंशियल इक्वेशंस which are of first order but not of degree 1 and derivatives are multiplied by the dependent variables। तो इस टाइप की इक्वेशंस जो हैं वो क्या कहलाएंगी, नॉन लीनियर फर्स्ट ऑर्डर इक्वेशन। अब ये एग्जांपल देखें इसकी, सीधा एग्जांपल डिवाइड बाय dx स्क्वायर प्लस डिवाइड बाय dx माइनस 3 इक्वल टू 0। दिस इज द फर्स्ट ऑर्डर इक्वेशन and due to these two, this is not first degree, its degree is 2, the first order and degree 2. This is the non-linear first order differential equation, and also x square divided by dx square plus xy divided by dx minus 6y square equal to 0 is also the non-linear and first order differential equations. Now how we solve these equations? These are non-linear equations. So already we have solved the linear equations. We learned about how to solve the first order linear equations. Now we understand how to solve the first order non-linear differential equation. किस तरीके से हम इसको solve करेंगे। ये इक्वेशन हमारे पास कौन सी है, नॉन लीनियर फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन है। तो द इक्वेशन सॉल्वेबल फॉर पी। अब इसमें कैसे होगा कि p की वैल्यू हम सपोज करेंगे डिवाइड बाय dx के बराबर। वी टेक p को डिवाइड बाय dx इन द डिफरेंशियल इक्वेशन एंड देन सॉल्व दीज इक्वेशंस। फिर उसके बाद हम इनको सॉल्व करेंगे, जहाँ यहाँ डिवाइड बाय dx है वहाँ p लिखेंगे आप, और फिर इस इक्वेशन को आप सॉल्व करेंगे। तो यहाँ पे नेक्स्ट पेज पे जो हम एग्जांपल एक्सप्लेन कर रहे हैं, जिससे आपको अंदाज़ा होगा किस तरीके से हमने ऐसी इक्वेशंस जो नॉन लीनियर और फर्स्ट ऑर्डर हों उनको किस तरीके से हमने सॉल्व करना है। अब यहाँ पे एग्जांपल देखें, सी द एग्जांपल, सॉल्व द इक्वेशंस। एक्स स्क्वायर पी स्क्वायर प्लस एक्स वाई माइनस वाई स्क्वायर माइनस वाई इक्वल टू 0। तो दिस इक्वेशन इज द नॉन लीनियर एंड फर्स्ट ऑर्डर। दिस इक्वेशन कैन बी रिटन इन दिस फॉर्म by taking the factorization method. By using the factorization method, we arrange this as x square p square minus y square, then xy minus y equal to 0, and this term can be written as, इस term को हम लिख सकते हैं xp minus y into xp plus y, and after that xp minus y. So in this equation you see xp minus y is common. So xp minus y we take common from this term. We have xp minus y into xp plus y and plus 1. These are two factors. Now we separately solve these factors. So we can write it as xp minus y equal to 0 and xp plus y plus 1 equal to 0. Now in place of p we put dy by dx, and we can write it as x divided by dx equal to y, and by separating the variables dy by y equal to dx over dx, and then take the integral. The integral of this term dy over dy equal to natural log of y, and integral of this is natural log of x plus log c. By property of log, this can be written as log cx. Log we cancel, and we have y equal to cx. Similarly, in place of p we put dy by dx, and this become x divided by dx plus y plus 1 equal to 0. By separating the variables we can write it as x divided by dx equal to minus y minus 1, and we can write it as also as dy over y plus 1 equal to minus dx over x. The variable been separated, यहाँ से वेरिएबल अलग हो जाते हैं, और अब क्या करेंगे, we take the integral both sides. इसका इंटीग्रल क्या होगा, द इंटीग्रल ऑफ दिस इज log of y plus 1, and इंटीग्रल ऑफ दिस इज minus log x plus log c. This term can take to this side, and by using the property of log we can write it as log x into y plus 1 equal to log c. Log will cancel, and we have xy plus 1 equal to c. अब नेक्स्ट पेज पे जो है आप देखें कि इसको जो है किस तरीके से आगे हम सॉल्व करेंगे। सी दिस, We have y equal to cx, and this can be written as y minus cx equal to 0. And also x into y plus 1 equal to c, and we write it as xy plus x minus c equal to 0. We have these two terms, and by multiplying these two terms, we have the solution, general solution. So the general solution is y minus cx, this is y minus cx, and into xy plus x minus c equal to 0. So after finding these two equations, we multiply these equations and we have the general solution. Now we start an exercise, the equation solvable for p. Differential equation p square plus p minus 6 equal to 0. We solve this equation. First we factorize this term. We can write this factor of p square plus p minus 6 as p plus 3 into p minus 2 equal to 0. So this can be written as p plus 3 equal to 0 and p minus 2 equal to 0. In place of p, we put dy by dx, and this can be written as dy equal to minus 3 dx. By taking integral both sides, integral of dy is y and integral of dx is x. This is cost of integration. So we can write it as y plus 3x minus c equal to 0. Similarly, in place of p, we put dy by dx. This 2 is taken to the right side, and we can write it as dy equal to 2 dx. Integrating both sides, integral of dy is y, integral of dx is x plus some constant. We can write it as y minus 2x minus c equal to 0. So these are two terms. To find the general solution, we multiply these two terms. The general solution is y plus 3x minus c into y minus 2x minus c equal to 0, the required solution. Now we see the question number 2 of this exercise. Solve the differential equation x square p square plus xyp minus 6y square equal to 0. By method of factorization, we can write this term as x square p square plus 3xyp minus 2xyp minus 6y square equal to 0. Now, from this step, take xp as common. So we have xp plus 3y. Because this xp is common, we have 3y. And from this step, take minus 2y common, we have xp plus 3y equal to 0. So xp plus 3y, and this is xp plus 3y, and we take the common xp plus 3y. We have xp plus 3y into xp minus 2y equal to 0. So this is the factorization method to solve the equation solver for p. Now this can be written as xp plus 3y equal to 0 and xp minus 2y equal to 0. In place of p, we put dy by dx and take this 3y to this side, and by separating the variable, we have dy over y equal to minus 3 dx over x, integrating both sides. Similarly, in place of p, we put dy by dx minus 2y equal to 0, and this can be written as x dy by dx equal to 2y. And by separating the variable, we have 1 by y dy equal to 2 into dx over x, integrating both sides. The integral of this is natural log of y, integral of this is minus 3 log y, integral of this is log y, and this is equal to 2 into natural log of x plus some constant. We have log y equal to minus 3x log x plus log c, and this is log y equal to log of x cube into x to the minus 3 into c, and log will cancel, and we have y equal to x to the minus 3 into c, and y minus x to the minus 3c equal to 0. Similarly, this can be written as log of x square into c. This 2 will become power, and by property of log again, the term will be multiplied and log will cancel, and we have y equal to x square into c, and y minus x square c equal to 0. The equation 1 and this equation 2, and by the general solution of the equation is y minus x minus 3 into c into y minus x square into c equal to 0. We multiply these two terms and we get the required general solution. Now question number 3, solve the differential equation p cube minus x square plus xy plus y square into p plus x square y plus xy square equal to 0. So multiply p to these terms and then arranging from this term, taking p as common, we have p square minus x square. And we arrange this minus xyp and this plus x square y and minus y square p and xy square equal to 0. And this can be written as p into x, p plus x and p minus x. And from this term we take common minus xy and we have p minus x. And from this step we take the common minus y square and we have p minus x. So this is p minus x, p minus and p minus x. So in this equation we take p minus x common. When we take p minus x common, we have p into p plus x minus xy minus y square equal to 0. Now by arranging this term p into p square and this minus y square can put here, and px and minus xy equal to 0. So this term p square minus y square can be written as p minus y into p plus y, and from this step we take x common, we have p minus y. So this p minus y is common. P minus y and p minus y we take common and we have p plus y plus x equal to 0. So we have the three factors. Separately we solve these three factors. So first factor is p minus x 0 and second is p minus y 0 and third is p plus y plus x equal to 0. In place of p we put dy by dx and this can be written as dy by dx equal to x. So this can be written as dy equal to x into dx, integrating both sides. Integral of dy is y and integral of x is x squared by 2 minus c1. c1 is the constant of integration. Multiplying by 2 we have 2y equal to x squared minus 2c1. Now we solve this. P minus y equal to 0. In place of p we put dy by dx and we can write this as dy over dx equal to x. By separating the variables we have dy over y equal to dx and take integral both sides. Similarly solve this step. P plus y plus x equal to 0. In place of p we put dy by dx and this can be written as dy by dx plus y equal to minus x. This is the equation. You see linear equation, linear in y. So first we find the integrating factor. Here value of p is 1. 1 is multiplied by y and we take p as 1. Integrating factor is e to the integral 1 into dx. Integral of this is x. So integrating factor is ex. We multiply this equation by ex. Ex into dy by dx plus ex into y equal to minus x into e to the x. So this step can be written as derivative of ex into y. This was the first step. 2y equal to x squared minus c and in place of 2c1 equal to c, so we have 2y minus x squared plus c equal to 0 and this is log y equal to x plus c1 and this can be written as y e to the x plus c1 and this can be written as y equal to ex into ec1. In place of ec1 we put c. So we have y equal to ex into c and this is y minus ex equal to 0. So this equation was from the last page. We say that this become d over dx, ex into y equal to minus x into e to the x. Integrating both sides they will cancel. We have ex into y and integral of x into ex by integration by parts. X same, integral of ex is x minus integral derivative of x is 1 and ex. Integral of ex is ex minus and minus become plus. So we have ex into y equal to minus x ex plus c and dividing this equation by e to the x. We have y equal to minus x plus 1 plus e minus x. This is y plus x minus 1 minus e minus x. So we have these equations. We multiply these equations. So we have the general solution is 2y minus x square plus c into y minus c ex into y plus x minus 1 minus c minus x equal to 0. This is required general solution of the equations. In the next lecture, we will solve the equations which are solvable for y. These are the equations solvable for p, and in the next lecture you will see the equations solvable for y.